Hey there, Happy New Year. It is 2021, almost.
It's 12 o'clock.
Actually, it is 12 o'clock. So, Happy New Year, 2021. I am observing on the North Pole tonight, or otherwise known as my backyard, Minneapolis. And you can see the telescope there, hear the fireworks. Here is the full moon somewhere up here. So actually not the best night to be observing with the full moon, but so I wanted to kind of nerd out here and just show my setup here. So I'm using for the first time a guide scope. It is a guide camera attached to the telescope, and on the top bar here, these are the deviations of the telescope, and what it's doing is constantly nudging the telescope in the right direction. So every second it's taking a picture of stars. It's a little bit tough to see here, but there's a picture of a single star there, and it's tracking where that star falls every second on basically on the bullseye here. Now I have it paused because I'm outside on the deck. But if it was actually doing it live, you would see that little red dot bouncing around and around. And the cool thing is, every time it moves up, it nudges the telescope down a little bit. Every time it moves left, it nudges the telescope right. So what you see, in fact, is like basically how tight the stars are going to look on the image, which this is zoomed in like something like 1,000 times, literally. So, and it's actually really cool to see in action. I'm sorry, I don't have it going here. But what you see here, that when that red line deviates down, that means the star is moving down a little bit. Now, that was actually intentional there for a confusing reason. But then it levels out and it nudges it up and down just a little bit. And again, that little line is like 1,000th of a degree there. So I am auto-guiding my telescope, and what I'm able to do now is I'm taking continuous 5-minute exposures with my Canon 5D, and so I'm imaging the Messier 78 nebula. It's a cloud of gas being lit up by two super hot stars about 1,000 light years away, and we can see it pretty easily through your telescope here, and Oh, I just deleted. Let me get the last image I took, and I will show it to you here in a moment. So here's this was last image taken a few moments ago. Now it's really tough to see with the colors as they are here, but those two bright stars in the center, the two bright stars in the center there, if I was able to dim the screen down a little bit, which I can't in this view, you would see kind of a big glow of diffuse light surrounding them. So anyway, that is how I just spent my New Year's. So Happy New Year's. Let's hope 2021 doesn't suck as bad as 2020.
Hey, okay, so part two here. I want to show how this guiding software actually worked in action here. So I have, like I was trying to show on the phone camera, I have a graph here, and this is showing the deviations of the telescope. The blue is left, right, the red is up, down, and the little pulses here are telling me literally what pulses the guide software is sending to the telescope. Now, if you can see here, my pulses are almost all going northwards or upwards. So what that means, my alignment's a little bit off, which I need to correct that later, but it's no big deal. And then now down here, this is like the bullseye, and you can see like every dot is where the telescope was pointed at that second. So we're seeing a little bit drifting north, or whatever up is on this here. So it generally shows the dispersion or the spread of basically how accurate the telescope is without a guider. Now, the nice thing is it bumps it back to the center every time, so it really does stay very centrally focused, which is what we want. And the smaller the number here, the smaller the peak. What this is actually a profile of an individual star from the guide camera. So it's centered at a pretty small amount of resolution there, which is great. So I have pretty good seeing conditions tonight. And then the really cool thing here, we can look at what the overall basically deviation from center is. And in the left-right direction, it's about 2/3 of what we call an arc second. It's a 60th of a degree. So I have just a very small deviation, a very tiny fraction of a degree left-right, and almost exactly the same up-down. And so what that means is my overall RMS error, or my overall basically like spread of my stars is going to be less than 1 arc second on my image, which is going to be something like, many thousands of arc seconds across. So that means it's going to be incredibly tightly focused for a final image. And that's how you bring out the huge amount of detail that you can have with these 8 or 10-inch telescopes. And then here is the software that I'm actually using. I'll be fairly brief on this, but basically what I have here is scheduler for all of my observations. Now here's a zoom out of the previous image that I just had. Let's see, I'll make it a little bigger. I'll talk, yeah, so you can see there's a very faint nebula at the center, and we can see it a little better here. So there's a very faint nebula, and this is what I was talking about. There are two very bright hot stars that are illuminating the gas around it. So that's M78 or Messier 78. So it was my last image, and the next one should be coming in here in, I think it was about, let's see, in about 80 seconds left until I get my next image. So it just overlaps image after image. And right now I have it set for 300 seconds or 5-minute exposures. And I'm doing 24 of them at this run here. So that's 2 hours worth with a 15-second delay to let the sensor cool off a little bit in between. And one other thing that I have is set for it's called mirror lock, where instead of the mirror flipping up and kind of jostling the telescope, it locks the mirror up in place. So basically there's no jostling of the telescope due to the mechanical motion of the camera. And then here's a even cooler plot of the guiding software in this software here too. So this is all built into a really cool planetarium software called KStars, and I have. So you can move around, you can see, you can search for other types of objects. But right now I have it centered on Orion, which hopefully many of you know. This is the Alnitak, Alnilam, and Mintaka, the 3 stars of the belt, which you should all be able to see. And right here we can see, oh, it's shifted a little bit, but it's showing exactly where I'm viewing. Yeah, literally, so what I did is I submitted my image and it fit and it found exactly where on the sky the telescope is pointed, which is just awesome. You can literally submit an image. It knows exactly where in the sky it is based only on the stars there. So it's told me real time exactly where the telescope is pointing and where the images are being taken. And if you zoom in further, you can see this is ideally what the image is going to look like once I process the hell out of it, basically. Oh, here's the newest one. And yeah, you can see just a vague amount of nebulosity there in the middle. I'll try to bring it out a tad more. It's pretty nice built-in software. And then let's zoom all the way in. Yeah, so you can more or less kind of make it out here. It's when I stack all of the images together, so instead of just a 5-minute exposure, if I have like a 3-hour or 4-hour exposure, it really brings out that faint detail. And so that's the whole point of taking many long exposures and using that the guide scope. I'm able to keep it perfectly tracking to within a single pixel is what it translates to. So notice how perfectly round and perfectly smooth the stars are. And that means that it's tracking really, really well. So the stars are just little pinpoints. Oh, and by the way, these little spots are just very faint spots of dust, either on the telescope or on the camera itself, and those are taken away or they're corrected for by using what we call flat fields. So I'm going to subtract what that image looks like with a white background. So I subtract for that dust in the end. So that's actually nothing to worry about at all. Same with the kind of the vignetting here. I'm going to crop it out, but even with that, you can see there's still some color gradient that will be also corrected for by the flat fields. And fortunately, there's no hot pixels that I need to worry about or anything like that. That would be corrected for by darks, which I will use too. So that's more detail I meant to go into, but that's basically how I have spent my New Year's Eve. It is now, what time is it? 12:32 on Friday, January 1st. So I'm sitting here doing astronomy. All right, happy New Year and happy observing.